Hi friends, welcome to Follow Up. Let's have a look at today's daily challenge problem. Problem 2251. Number of flowers in full bloom. In this video, we are going to explain a solution based on binary search. So overall, I feel that for this problem, the logic is important, while for the coding, it's actually rather routine. So this problem is marked hard by leetcode. Actually, once we digest the logic, the problem actually is not very challenging. So here we are given a zero index to the integer array called flowers. So each element in this list basically is another length 2 list containing start time and end time. So basically it says that the ith flower will be in full bloom from start I to end I inclusive. So this condition, inclusive, is important, right? So we are also given a zero index integer array called people of size n. So where people I is the time the ith person will arrive to see the flowers. So we want to find an integer array called answer of size n. So here n equals the length of the size people, where answer I is the number of flowers that are in full bloom when the ith person arrives. So here we have two examples. So I'm going to look at example 1 in some detail and comment on example 2. So first, look at the example 1. So the first people arrives at time 2. So in this time, so we have only the first flower in full bloom. So the corresponding number is 1 in the output. Well, for the person 2, he or she arrives at time 3. So this time falls in the interval 1, 6, and 3, 7. So notice that because this is inclusive, right? So the return is 2. So similarly, you can interpret the other 2's in the output. So this is for example 1. Well, for example 2, so you can do the same digest as in example 1. But here I want to mention that the different people might arrive at the same time. So here, the first and second people both arrive at time 3. So with that said, it's also important to look at the constraints for this problem. So here, the flowers can be as long as 5 times 10 to the power 4. And the people length can be as long as 5 times 10 to the power 4. So in other words, we need to take consideration of time complexity when we do the coding. So I guess for this problem, the hint is very suggestive, right? So basically it says that you can use it provides a way to check how many flowers are in full bloom during that time t. So basically notice that for any given time, the number of flowers blooming at time t is equal to the number of flowers that have started blooming minus the number of flowers that have already stopped blooming, right? So we compute a difference. Well, this two piece of information, the number of flowers that have started blooming and the number of flowers that have already stopped blooming, are very easy to retrieve if we use binary search after we do some thought for preparation. So with that said, let's look at the analysis. So before we look at the analysis, I want you to point out to you some information. So if you have time, it might be good to look at leetcode problem 34. That is, find the first and last position of element in sorted array. So this is very relevant, right? So essentially, we can use the idea in problem 34 to solve this problem. So in the video for leetcode 34, so we give two solutions. One is implementation from scratch, and two is using bisect module. So again, here in this problem, we're going to use binary search, but here we are going to use the bisect module directly. So let me walk you through the main idea using example 1. So here is the flowers, here is the people. Then if we retrieve the start times and then make it sorted, we get 1, 3, 4, and 9, right? And then if we look at the ends, we have 6, 7, 12, 13. They are already in sorted order. So we make them sorted to do or revoke binary search. So now let's look at the first people. So the first people arrives at time 2. So then if we examine the starts, so we see that there's 1 already beginning bloom. So in this case, n started is 1. So the number of started flowers for blooming. And then we want to check if there are some flowers already stopped. So in other words, we want to fetch the end, which is strictly less than this number 2. So if you examine this, there's no. So we have an ended is 0. So the number of flowers this people can see at this time will be 1 minus 0, that is 1. So now if we look at the second people, he or she arrives at time 3. So then we want to find the time that is less than or equal to this time in the starts. So that is 1, 3. So we get a 2. And then also we want to find the time that is strictly less than this 3. So there's no, so we have 0. So the number of flowers this people can see is 2 minus 0, that is 2. So to further proceed, let's look at the third person. The third person arrives at time 7. And then we look at the starts. We find the number of items that is less than or equal to 7. So we have 3. That is the 1, 3, 4. So that it means n started is 3. So we also want to find the number of flowers that already stopped blooming. So we want to find the number of items in ends such that the time is strictly less than 7. So we have 6, that is 1. So it means n ended is 1. So the number of flowers this people can see is 3 minus 1, that is 2. So now for the last person who arrives at 11. So we know that all the starts are less than or equal to this 11. So we get n started is 4. And then we want to find the number of items in ends that is strictly less than 11. That is 6 and 7. That is 2. So then we get the number of flowers this people can see is 4 minus 2. That is 2. So this is in match with the output in example 1. So with that said, we are ready to writing the code. We're ready to write the code. So first I can get the starts, right? So we can use list comprehension. So for x in flowers. So this retrieves the first element, start time. So x1 for x in flowers. So this will retrieve the end. So we can do a sort in place. Let's see, start sort and sort. Great. So now let's let's prepare the return. So let's initialize a list variable called result, and then we are going to scan the people for t in people. Right. This t means arrival time. And then we want to find the number of flowers that are already bloomed. So this I use the bisect module. So here we use bisect left, right? So we want to search in starts. So notice that when we do the for loop, the starts is already in sorted order. So we want to find the elements which are less than or equal to the t, right? So this index will be the number of flowers blooming. And then I started blooming. So now let's also find the ends, right? And ended. So this will be bisect. So here I'm going to use bisect right. So we want to find from ends. We want to know which flowers have already stopped blooming. So in other words, we want to find items in the ends that are strictly less than this t, right? So with that done, so we have the required information, the 2 pieces of information. Then what we want to do is to append this piece of information. So n started minus n ended to this result list. And finally, we do the return. So this actually forms a full solution to this problem. So now, before we move any further comments, let's first do a test. So we rank. So let me do a check. So here we have x, right? We have x1, start, yeah, start, end. Then we use bisect left. So and we use so here is n started minus n ended. So let's see, what's the problem here? Starts, ends, and then we do the start, and then let's test. Always see what's the problem. Let's see result. Bisect right. Oh, so here, guess we get the. So here we need to bisect right, and here we need to bisect left. Let me start. So here for start, we want to find the time in starts that are less than or equal to t. So this means we use start right, because the right element will be strictly larger than t. The left one will be less than or equal to t. So for the ended, we want to find in the ends that are strictly less than t. So here we use bisect left. So now let's do a test. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the cases. So that's basically about it for this specific problem. So here I want to make two comments. The first one is that as you can see in example 2, right? So the people can arrive at the same time. So you have two threes here. So this is also a point that we could do a slight optimization, right? For example, you just compute once for the same number, right? You can use dictionary to make this happen. So that's the one part. Another part is the way we get n started and n ended. So here we are directly using the bisect module, right? But based on the solution in leetcode 34, if you look at the first implementation from scratch, you can actually retrieve these two pieces of information by coding from scratch. That would be a good practice. So with that said, I guess that's about it for this video. Thank you.